flip your paper to the other side. I want to review and I want to go back over the first things we were doing yesterday. Okay, first off, we've got our x and our y axis, and we had our parabola. Okay, in this parabola right here, this is the quadratic parent function. Write that down. Quadratic parent function. On the blank. Oh, is there not any room on the back? Let me see on the paper. Yeah, there's a little bit of room on the back on the bottom, so go ahead and write that down there. Quadratic parent function. That is y equals x squared. That is the simplest form of a quadratic function. Everything is going to come off of that. Okay? When we have things, like we'll have other equations that'll say y equals x squared plus 2. Right now in the quadratic parent function, what's being added back here at the end? No, I'm saying like in the quadratic parent function. Some people are saying plus 2, but what? In this one, it says y equals x squared, and if there's not a number listed, what number is that? It is 0. That's because this vertex right here is sitting on 0. When I get a new equation that now says plus 2, that shifts and moves my parabola up 2 units. Now, that vertex is sitting up there at plus 2. That's what this n number does. It either moves it up, so this moved it up 2 units, okay? Or if you had the equation y equals x squared minus 2, okay, and I'm talking about from the parent function, then the yx squared minus 2, it would be down here. Can you work it with what? Like if it was y equals x. Okay, the question was, can I use it when it's y equals 3x? And that's actually what we're going to do today. Okay, we're going to talk about what happens when there's a number in front of the x squared. Okay, right now this is just what happens when there's a number added or subtracted at the end. When a number is added or subtracted at the end, it's going to shift your parabola up or down. Okay, that's what the number here at the end does. So this shifted it down 2 units. Okay. By changing this number at the end, by adding or subtracting a number at the end, it did not change the width. It did not change anything from the width of the parabola. It still stayed the same. The only thing it changed is where it was on the graph, up or down. So now when we go and look on our sheet, on the front, let's look at this. It says use the graph below to fill in the tables and boxes besides the graph. Answer the questions that will follow. Okay, y1, the first one was at -2. Let's go over here. Let's see, y1 looks like it's the blue line on mine. So I've got over -2 and up right here to 4. So I've got -2, 4. Then -1, go up to the blue line, and it's 1. 0, 0. 1, and up to the blue line is 1, so 1, 1. And 2, and up to 4. Just from the blue line, from the points we have here, we should already be able to tell what our vertex is. What number is our vertex? 0, 0. So even on yours, you might want to circle this. I was talking about this yesterday. Circle it. And write the word vertex. How can I find symmetric pairs in my table? Can anybody give me a set of symmetric points? -2, 4 and 2, 4 are symmetric pairs. The y numbers are the same. They're the same on each side of the axis of symmetry. Remember, axis of symmetry is where we can fold our line in half, and it's the same on both sides. Now let's look at the red line. The red line says at -2, so let's say at -2, let's go up to the red line. Looks like it's up a little bit higher than 6. Looks like it's 7. Or let's see. No, let's see, try 8. It's kind of hard when they're squished together like that, but especially on your papers if it was smaller. -2, 8 over -1 and up to 2. Zero, 0 again. And over 1 up to 2. Over 2 and up to 8. Okay. Now in this table of the red parabola, what's the vertex? 0, 0 again is the vertex right here. Give me a set of symmetric points. -2, 8 and 2, 8. The y numbers are the same. Now, what do you notice about these two graphs when you're looking at it? They are kind of the same, but what would be, so they're, okay, so wait, let me ask you this. How are they the same? Okay, I'm going to get there in just a second. They're the same because they have the same vertex, right? Don't they both, is that what you're telling me? They're good, both go down to 0, 0. They have the same vertex. They both open upward, right? And they're both parabolas. How are they different? One's wider than the other one. One's skinnier. CJ, what do you notice about in the table? How are my y numbers? What's happening with my y numbers? You're multiplying by what? Look, 4 times 2 gave me 8, right? 1 times 2 gave me 2. The zeros stay the same because anything times 0 is 0, right? The y's, they did double. So let's see what's happening when we have our equation. Now let's find my, well, golly gee, what happened? Let's see, my first equation, which was the blue line, right here, this is going to be y equals x squared. And you guys are going to have to know that in the linear or the quadratic parent function that this is what the table looks like. Because all we're doing is squaring this number to get the y. The vertex we already said was 0, 0. AOS means axis of symmetry. And that's where you fold the parabola in half. And it's going to be, let's see, where is it right here? Here is my axis of symmetry right there. It's the y-axis, but what's the equation of that line? X equals 0. Didn't mean to write in that yellow, but that's okay. It's x equals whatever the x number is of the parabola. So it'll be x equals 0. The next one over here, for my equation, I know it's got to be some kind of x squared because it's a parabola. Now we just went through and said, how are we getting from the parent function to these numbers in the red? Multiplying times 2, right? The coefficient should be 2. We'll talk more about this in a little bit. The vertex, again, is 0, 0. My axis of symmetry is still the same. X equals the x number of the vertex, which is x equals 0. Which one is skinnier, the red or the blue? The red is skinnier, right? Okay, so what? And then notice here that red is skinnier, and it has a number being multiplied in front of it. We'll come back to that in just a little bit. It said compare the graphs of y1 and y2. Well, y2 is skinnier. And we really, I mean, instead of writing it all down, we did already talk about how are they the same and how are they different. That is going to be how you have to do part of the test questions, okay? You're going to have to be able to compare them. Then it said compare the tables. The y2 equation was being multiplied by 2. Which is what we just talked about up here in my table. How are we getting from these in the blue to the red? Compare the equations. Well, y2 has a coefficient of 2. Or you could say that y2 is being multiplied. You know, you're multiplying by 2. Compare to the vertices. The vertex on each one of them, they're the same. They are the same. They are both 0, 0. We talked about that as well. Compare the axis of symmetry. They are the same. They are both box. They are box. Way to write. Okay. They are both x equals 0. It says list 2 pairs of symmetric points for each one. When we look at y1, which is the blue one, we already talked about that one set is negative 2, 4 and 2, 4. So let's go back on our paper here and let's write negative 2, 4 and 2, 4. The other one in that table was negative 1, 1 and 1, 1. In symmetric points, what is the same? The y numbers are the same, right? In the red. So when I look up here in the red, you guys have it there on your paper. We have negative 2, 8 and 2, 8. And the other one was what? Negative 1, 2, and 1, 2. Did I miss? Oh, golly gee. Okay. Yeah, let me fix that. I got you, because the Y ones were supposed to be across the top, right? Okay. Didn't mean to erase all that. Let's do negative 2, 8 and 2, 8. Negative 1, 2 and 1, 2. Again, reminding ourselves that on symmetric points, the y numbers are the same. Now, let's see if I can get this right in the right order. The domain of y1. What is domain, x or y? Domain is x. I would put x above domain. Range is y, so I'll put a y above range. It says the domain of y1. So if we go up here to the top, domain of y1. What are my x numbers in y1? I'm talking about the blue ones right here, the blue line. -2, -1, 0, 1, and 2. Okay, what if I was going to have to write all of the numbers for the domain? What's happening to my my parabola on my x-axis? What's happening to it? What's this? The width, it's expanding, it's getting bigger, right? My blue line here, as it, let's see if I can move up a little bit. As I keep going with this, oh, I guess I took a picture of it. When I keep going, this will keep going wider and wider and wider. It won't go wide very fast, but it will keep getting wider and wider, okay? And if we had a giant graph that went on forever and ever and ever, it would continue to get wider and wider and wider, okay? So with that, what we're going to write is all, where is it? All real numbers. Meaning that it's going through every decimal, every point, positive and negative, on the x-axis, getting wider. But the range, on the other hand, the range is the y. What is the smallest y value? I think I heard it. 0. Isn't the y number right here starting at 0? And which way is it going? Up or down? Up. What numbers are they not hitting? The what? The negatives, right? So the y numbers for the blue is all positive numbers, right? Because it'll keep going up and up and up if we had a graph that could go on forever. So here we're going to write all positive numbers. Now we could write it like this. This is one way you may see it on a test. Y is greater than or equal to 0. Remember when we had to write the inequality at the beginning of the semester where it said all the positive numbers? How would you write it? You know, like x, oh, it was x is positive. And you had to write it x is greater than 0. Same concept. So now when it talks about the domain of y2, domain is x. What happens to my x and my red one? It keeps getting wider and wider and wider as it keeps going, right? It doesn't get wide. It gets wider slower than the blue one, but it'll still keep getting wider and wider, okay? So the domain is going to be all real numbers. What about the range? What about the y? When I look at my graph on my y, what's the smallest number it is? 0. And it goes up or down? Up. So it's going to be all what? All positive numbers. But I promise you it's going to be written y is greater than or equal to 0. What would that, hey, what would the range be if the parabola opened downward instead? Instead, if the parabola opened downward, it would be less than, okay? Because it opens upward, it's greater than. Maybe on your paper right now you need to make a note that if the parabola opens upward, it is greater than. If the parabola opens downward, it's less than. look at the next one. Now, I've got my two red-blue graphs again. We're going to go with y1 is the blue one. Let me bring this up here. I got this too low. All right, there we go. All right, let's find the points. On the blue one, -2, so I go over to -2, and I'm going to go up to 4. -2, 4. -1, over -1, and it's up at 1. -1, 1. 0, 0. 1, 1. And 2, 4. Right now, they're just, that question was, are we always going to have to go and find the symmetric pairs and find them on each side? Right now, what we're trying to do is they're trying to show us a new rule that we're going to have for making things skinnier and wider. I know that you're going to have to be able to, on the test, identify the symmetric pairs, but you're not always going to have to write them down in a table. Okay? Only in these cases right now, remember, because yesterday's when we shifted them up and down, the vertex is going to be like whatever it's adding and subtracting at the end. Like if it was x squared plus 2, the vertex is up at 2. If it's x squared minus 4, the vertex is down at minus 4. These are going to, if the vertex is at 0, it's just going to be a plus 0 at the end, which we don't write. What has to have the same x and y? No, like if your equation was, the question was, does a vertex have to have the same x and y? If you had y equals x squared minus 2, your vertex is 0, -2. So it's not always the same number. It's going to be 0 in something right now because it's always, for what we're doing, it's always going to be on the y-axis. Okay, it's going to be 0 and whatever that last number is right there. Is that what you were asking me? Okay. Show me your paper. Next. Now, you guys have to be able to show me or know that this right here is going to be the equation of the quadratic parent function. And so you need to see that that's going to be y equals x squared. Now, let's see what happens in the red. -2, I'll go over -2, and where is this one? -2, oh, and 2. -1, and that looks like it's 1/2. 0, 0. 1 and up to, looks like it's 1/2. And 2 and 2. With what? Yeah, the question was keep it as a fraction or decimal. Either way, it doesn't matter. You can put it as 0.5, yes. So let's just say, oh, let's just do that. Let me erase this. Let me put that in there as 0.5 instead. Let's go 2, 0.5, 0, 0.5, and 2. What do you notice? Let's start with this. Out of the two parabolas, let's name some things that are the same. What are the same between these two parabolas? The vertex is the same. What is the vertex? The vertex on both of them is 0, 0. That's because both of them have a minimum point of 0, 0. How else are they the same? They both open upward. There's one other thing that's the same. I heard it. What? Axis of symmetry, AOS. This is your line where you can fold that parabola in half. It's right here. What's the equation of that line? X equals 0. Okay, so all those are the same. What's different? One's wider than the other. Here, the blue one's my parent function. The red one is wider. Guys, what is happening right here in these numbers? Let's think about dividing. We're dividing by 2, right? Half of, if you took 4 divided by 2, you would get 2. If you took half of 1, that's 0.5, right? 0 doesn't change because anything divided or multiplied by 0 is 0. Half of 1 is 0.5, okay? So my equation y equals 1/2 x squared. So when I multiplied on the last one, when I multiplied by a whole number, right? What happened to it? So when you multiplied by a number bigger than 1, it got skinnier, right? This is a fraction. What happened to this one? It gets wider. Here's how I look at it. A fraction, if your coefficient is a fraction. Oh, goodness gracious. A fraction. The parabola, parabola gets fatter. Now, why do you think I'm trying to use fatter? What hint am I trying to give you? F and F. Fraction means fatter, okay? When the fraction is between 0 and 1. When your coefficient is a number larger than 1, it gets skinnier. Again, I'm just trying to find a way for you to remember what's happening. Now, you always do have the calculator to put it in there, but when you're comparing fractions, like say it's y equals 1/3 x squared and y equals 3/4 x squared, okay, you're going to have to be able to tell me which one is skinnier and which one is fatter. Questions about that? Okay, oh, I know, down there in the questions, though, for the most part, I've answered down here. Let's see, the first one, I don't know why these are so low. On the blue one, the equation is y equals x squared. This is your parent function. The vertex, 0, 0. AOS, at x equals 0. In the red, y equals 1/2 x squared. Vertex, 0, 0. Axis of symmetry, x equals 0. Those are all the things that we've already talked about. We're just adding it in on our paper and answering those questions. If I move down just a little bit, because everything seems to be way down here. There we go. Compare the graphs. Well, that's what we did up here. We said what was the same. Okay, but we did see that y2 was wider, fatter, more plump, whatever you want to say. The tables, what's happening to the tables? y2, let's see, how do I put the y numbers in y2? The y numbers in y2 are half of y1. Or you can say that that y1 is being divided by 2. However you want to say that. Compare the equations. The coefficient of y2 is a fraction. The vertices, the vertexes, they're the same. They're both 0, 0. Right? We went over those. All that. What's the axis of symmetry? X equals 0. I promise that will be on your test. Let's see if I can find. All right, let's pull these up again. I think the symmetric points were okay on. I want to talk about domain and range. Domain, X. Range, Y. For the blue one, the domain, that blue one will continue to get bigger and bigger and bigger to the left and to the right. It'll continue to get wider, okay? So if it continues to do that, it's all real numbers. What about the range? The range is the Y number. My parabola opens upward. What's happening with my Y numbers? They're starting at what? 0, and they're going up. So that's all the positive numbers. So again, this is going to say on here that we're going to say Y is greater than or equal to 0. Yes. The question was, do you want you guys to start writing like this? Yeah, with the inequalities, yes. In the red one, again, the domain, the X is going to be all real numbers because it'll continue to get fatter and fatter. The range, again, in this one is Y is greater than or equal to 0. This number right here is going to be the vertex on whatever one. You're going to see it more often. That number will always be the vertex. Okay, so it should be the smallest or the lowest or the highest. The question was greater than or less than. If the parabola opens upward, okay, if the parabola opens upward, then it's going to be Y is greater than or equal to. If the parabola opens downward, that's when we have Y is less than or equal to. Okay? Right now, I want you to take a minute. I want you to answer number 1. I want you to go in the calculator. So what we're going to do, go to Y equals, and let's put in there X squared plus 5. Let's make sure we know what we're doing. We've got the X button that's up there by the alpha. The squared, where's the squared button? Right here, above, diagonal from the 7. Plus 5. Okay. Here's that parabola. Oh, man. Okay, we'd messed with our, in the other class period, we messed with our window settings. You may want to remember to clear your memory every time so that it's always set back to the default. Okay. So here's my parabola. The plus 5 is that vertex up there. Okay. My coefficient is 1. If I want to know if something is wider, the wider has to do with the coefficient. The coefficient here is 1. What does that number need to be wider? Be a fraction. So which one of these would it be? D. It would be D. Okay? On the next problem, it said when graphed, which function would appear to be wider and flipped? Well, wider, I know that my coefficient needs to be a fraction. But what makes something flipped? What makes it open downward? The coefficient needs to be negative. The coefficient needs to be negative to make it open downward. Okay? So first off, I need it to open downward. So negative coefficient, negative, negative. That one's positive. It's not B. But now I need a coefficient to be a fraction. So the answer would be D. The next one says, though, order the following quadratic functions from widest to narrowest. Remember, widest starts with your fractions. Narrowest goes to the larger number. Larger number. I want to remind you, though, that when we're talking about width, okay, the positive and negative don't have anything to do with it when I'm talking about how big the number is. Positive and negative only tell you how you're opening upward or downward. So if your coefficient is positive, you're always going to open, oh goodness, this board keeps freaking out, open upward. So your parabola would be opening up. If the coefficient is negative, it's going to open down. Like that. Okay? But this is only asking us from widest to narrowest. So what's the first one? The widest one is a fraction. Which one has a fraction? B. Now, going up with all these coefficients, what's the next biggest number? What number is in front of the x squared? A what? A 1. So next would be D because the 1 would come next. Then the 3. Then the 4. So this is in order from widest to narrowest, and you can put it in the calculator to make sure. Here's the next one. It says which function has a graph that has that is the same as a graph of f of x equals 3x squared plus 1 shifted down 4 units. Well, when we have 3x squared plus 1, this right here only changes my constant at the end. So if it shifts it down, I'm going to subtract 4. So now my equation, y equals 3x squared, that stays the same. 1 minus 4 is minus 3. So your answer would be D. Okay, so explain how changing the coefficient in front of the y equals x squared, the quadratic parent function, will affect the graph. Well, by changing the coefficient, the number that's here in front, the a, okay, by changing the a, first off, if it's negative, the parabola will open downward. If it is positive, the parabola will open upward. And the computer's freaking out here. Here we go, upward. If the number is a fraction, okay, and I'm talking about between 0 and 1, it will be wider. But remember I said to kind of think of it as fatter, because fraction starts with F, fat starts with F, and it will be skinnier or narrower when the coefficient is larger than 1. It really doesn't want to write for me today. Okay, let's look at this in the practice. It says, what is the vertex of Y2? So as I look into the Y2 column, I see that I have symmetric pairs because remember the Y numbers match up. 298, 298, 190, 190, 106. They have partners. What's the only one that doesn't have a partner? The -2, and then you go to the X number, which is 0. So the vertex is 0, -2. The vertex of Y3, look in the Y3 column, you've got symmetric pairs. You've got the numbers that match up, -16, -16, -9, -9. The only one that doesn't, 0 does not have a partner. Go over here to the X column, and so now we have, for this vertex, 0, 0. It says, what is the maximum of Y3? What is the highest point that Y3 gets to? It starts down here at negative and it goes all the way up to 0. See, because my parabola will be opening downward. So right here at the top, that'll be my maximum. It is the same. The maximum is the same as the vertex. Axis of symmetry. It's where you fold the parabola in half, and it's the same on each side. It says of Y2. It's going to be x equals whatever the x number is of the vertex. So x equals 0. Name 2 symmetric points for Y2. In Y2, match them up. It doesn't matter which ones you do. I'll choose -10 and 298 and 10 and 298. Remember, symmetric points have to have the same Y numbers. You could do the 190s if you want to. I'll go down here and do 4 and 46. What's its symmetric point? Well, there's the 46, so it's -4, -46. What is the minimum of Y2? Y2, these numbers are all large, so now they're getting smaller, smaller, smaller. This is the smallest number they get to, and they go back up. My minimum is 0, -2. Minimums and maximums are the vertexes. It just depends on if the parabola is open upward or downward. The range for Y3. Y3, you notice we already said that the parabola opens downward. So we're going to have Y is less than or equal to the vertex, which is 0. Why is it less than? Because the parabola opens downward, the range starts at 0 and it goes, it's all the numbers below it.